Hello, and welcome to the 2021 International Residential Code Code Change Update class. And thank you for choosing Wisdom and Associates for your education needs. Wisdom and Associates provides services for the construction industry, including code compliance inspection services for both residential and commercial buildings, existing home inspections for resale or maintenance, energy ratings on new and existing construction, both residential and commercial, indoor air quality investigations and research, and educational programs for the construction industry. Before going any further, we recommend that you download the class handout if you haven't done so already. You can download it from the link in the class receipt email you received or at the top of the class page. After doing so, watch the entire presentation video and then take the quiz and submit it for grading. Once your quiz has been graded, you will receive a certificate by email, usually within 1 to 2 days. Good luck! The International Residential Code is comprised of 43 chapters. The code is designed to cover all aspects of new construction from foundation to finish. The state of Alaska uses the International Residential Code chapters 1 through 10 for residential construction. Plumbing, mechanical, and electrical codes in Alaska are governed by the Uniform Plumbing Code, the International Mechanical Code, and the National Electrical Code, respectively. For energy conservation and ventilation standards, the state of Alaska has adopted the International Energy Conservation Code with amendments. For ventilation, the American Society of Heating, Refrigeration, and Air Conditioning Engineers Standard 62.2/2010 has also been adopted with amendments. The International Residential Code, hereafter referred to as the IRC, with Alaska-specific amendments, is the referenced code for residential structures containing 4 or fewer dwellings and townhouses not more than 3 stories above grade plane in height, and their accessory structures for the Alaska Housing Finance Corporation. The scope of this class is going to be to cover chapters 3 through 8 of the International Residential Code. Throughout the course of the class, we will highlight codes that are most relevant for Alaska and most commonly come up as questions for building contractors. Important changes from the 2018 edition of the code will be highlighted in blue. Let's start our code change review with Chapter 3, Building Planning. Any townhouses that are located in Seismic Design Category C, or any other buildings located in Seismic Design Categories D0 through D2, cannot be irregular unless designed and engineered in accordance with accepted practices to the extent that the irregular features affect the performance of the structure. Possible irregular conditions can include such features as braced wall panel placement, cantilevers, setbacks, and angled wall features. A new condition has been added to the 2021 edition of the code, which now includes hillside light frame construction. This type of construction most commonly refers to daylight basements, but would also apply to crawl spaces on sloped lots. In order to be considered irregular, all of the following factors would apply. 1. The grade slope exceeds 1 in 5 on any side of the building. 2. The tallest cripple wall exceeds 7 feet. In this instance, a cripple wall would be any wood-framed wall between the lowest floor and the floor above, generally resting on top of the foundation. Cripple walls are common where full-height foundation walls are not used on sloped sides of lots in order to save on materials. And number 3, less than 50% of the interior walls in the structure are finished. As we can see, these rules are really targeting the unfinished daylight basement. due to the imbalanced load on the foundation and the lack of shear strength from the unfinished walls. There is an exception to this rule, which does permit the downhill of a daylight side to be fully stick-framed if all other walls are full-height foundation wall from the slab to the floor above. This photo is an example of a potentially irregular building. Note the unfinished interior walls and the stepped foundation that has a cripple wall height exceeding 7 feet. Interior finish would be required on the walls to prevent this building from being considered irregular. A change to the live load table has occurred in the 2021 version of the code, where live load was changed to uniform live load, and a category for concentrated load was added. Interestingly, some of the concentrated load in the updated table comes from the notes in the 2018 version, but these notes, plus some new additions, have been added to the concentrated load category. There are a few interesting notes on this table to cover. One is that for passenger vehicle garages, the concentrated load applies to the garages with elevated floors. A garage floor can be framed up off of the grade level, but of course it would need a non-combustible surface, as we will see later. The 2,000-pound figure applies to a 4.5 by 4.5 square inch area, such as would be under a vehicle tire. This 2,000-pound figure was in the notes in the previous code edition table, but it only specified that the load be applied to a 20 square inch area and not specifically a 4.5 by 4.5 inch area. Stairways got a new similar requirement in the 2021 code with a concentrated load rating of 300 pounds on a 2-inch by 2-inch surface area, rather than an area of 4 square inches, which was noted in the previous code. There must have been some pretty creative ways these loads were being tested in order for this code to change. Handrails also got a concentrated load rating, although this rating already existed in the notes of the table in the 2018 version of the code. Handrails must withstand 200 pounds of force applied anywhere along and at any direction on the top. For dwellings with attached private garages, the private garage cannot open directly into a room used for sleeping purposes. Although bedrooms are not strictly defined in the code, sleeping rooms must have an emergency egress window meeting all of the requirements of this code, as well as a smoke alarm. So rooms that meet these requirements cannot open directly into a private garage. Doors that separate the interior of a residence from an attached garage must meet special requirements for fire separation and protection. The door must either be a minimum 1 3/8 inch thick solid core wood or honeycomb steel door, or have a minimum 20-minute fire rating approval. Windows are not permitted in these doors unless they are tested assembly and UL listed. A self-latching and automatic closing device is required on the door between the garage and the home. This is a significant change in the language from the previous code, which did not make any reference to the door being set to latch. For a garage man door to effectively block smoke, fire, and carbon monoxide from entering the living space, latching is crucial. This is just as important as the door's ability to self-close. Without a reliable latching mechanism, even a closed door becomes susceptible to air pressure caused by a fire, potentially forcing it open. Notably, however, the code does not spell out how the self-latching is tested, such as how far the door must be opened to accomplish the self-latching. This photo shows a door with a window that is being used to separate living space from an attached garage space, as you can see a car through the window. Unless this door has been specifically rated and approved for this installation, it is not code compliant and would need to be replaced with a proper fire separation door. Moving on from fire protection, let's take a look at minimum habitability requirements. Each habitable room in a dwelling must have at least 8% of the floor area in windows, and 4% of the floor area must be operable window. Two new exceptions have been added to the 2021 code. The first exception to this requirement is that windows are not required to be operable if a mechanical ventilation system has been installed that is capable of producing 0.35 air changes per hour of ventilation. This new exception dovetails with the state-adopted energy and ventilation codes, which also require mechanical ventilation. Operable windows that meet egress requirements are still needed in bedrooms and sleeping rooms. Operable windows can be omitted from kitchens where local exhaust is provided at a rate of 100 cubic feet per minute, which is also a requirement of the state-adopted energy and ventilation codes. Air intake openings, such as for ventilation systems, whether passive or mechanical, must be located at least 10 feet from any contaminant sources, such as chimneys, vents, or parking areas. An air intake can be closer than 10 feet if it is 3 feet below the pollutant source. This is a slight departure from the state-adopted energy and ventilation code, which does not have the 3-foot exception, so keep that in mind. The exhaust from dwelling unit toilet rooms, bathrooms, and kitchens is not considered hazardous, so there are no separation requirements for these exhausts from air intakes. Dryer ducts, however, are in their own category and must terminate at least 3 feet from openings into the building, which the code has been clarified in 2021 to include soffit vents. The amount of moisture produced by clothes dryers can be very damaging to the building, especially in the attic space, so dryer exhaust must be kept well away. The exhaust from clothes dryers is typically much warmer than the surrounding air and as such wants to rise into openings in the building above, such as soffit vents. The warm, moist air in the exhaust will condense on the cooler building components, especially during the winter, which can lead to a buildup of frost and moisture that will damage the home over the long term. A new ceiling height exception has been added to the 2021 code for non-basement areas. Beams and girders, which are spaced at least 36 inches on center clear finished width, meaning 36 inches between the edges of each beam or girder, can project down to 6 feet 6 inches. This graphic shows the newest change to ceiling height requirements for rooms other than basements. The ceiling height can be reduced from 7 feet to as low as 6 feet 6 inches where beams project downward, as long as the beams have a clear width of 36 inches from inside edge to inside edge. A slight change to the safety glass codes has happened in the wet surfaces section. Safety glass is required at windows or glazings enclosing wet areas such as tubs, showers, hot tubs, saunas, and similar fixtures and equipment. If the enclosing window is less than 60 inches vertically from the standing or walking surface, then tempered or safety glass is required. The only exception is if the window or glazing is more than 60 inches from the water edge of the bathtub, hot tub, whirlpool, or similar fixture. A slight change occurred here in the 2021 code, which removed the phrase "and in a straight line" from this section of the code. According to the commentary, this change is intended to clarify the 60-inch measurement from the water's edge to include windows adjacent to the water on any wall, not just those walls facing the wet area. The code assumes a person is just as likely to slip and fall to the side as to fall forward into the glass, and therefore the wet area around the tub or other fixture is treated just like the bottom of a stairway. This illustration shows the safety glass next to a tub or shower rule applies even to windows not on the same plane or facing the fixture. Any glazing within a 60-inch arc of the water's edge is included in the safety glass requirements if it is less than 60 inches above the standing or walking surface. Emergency escape must open into a public way or court or yard that opens to a public way that is 36 inches in width. The 36 inches in width is a new addition and clarification to the code which did not previously specify a width. This change brings the IRC in line with the IBC, which does specify a minimum width for egress courts from Group R3 occupancies of not less than 36 inches. There is also an exception for emergency escape from basements, provided that the basement is less than 200 square feet and houses only mechanical equipment. For proper emergency escape and rescue, the egress, whether it is a door or a window, must be operable from inside the room in which egress is required. The means of egress, again whether a door or a window, must be operable without keys, tools, or special knowledge. This means that deadbolts or similar locks or apparatus cannot be keyed on the inside. If the egress is greater than 6 feet above the adjacent ground level, a fall prevention device meeting ASTM F2090 must be installed. The fall prevention device cannot be more than 70 inches above floor level. This is a new addition to the 2021 code. This revision makes the operational and opening control device provisions in the IRC consistent with the same provisions in the IBC. A new addition to the code clarifies that the net clear opening by which the egress dimension is measured has to be from the normal operation of the window. The removal of stops installed in the frame, such as for hung windows that slide vertically, cannot be counted toward the net clear opening, since that would not be part of the normal operation. Another significant wording change in the 2021 code is that the height of the egress opening is measured from the floor to the bottom of the clear opening of the window and not the window sill. This is a change that has gone back and forth several times in previous code cycles. Measuring to the bottom of the clear opening may take a bit more planning on the builder's part rather than measuring to the sill, as the thickness of the window frame now plays an important part in the measurement of the egress opening height. This photo is an excellent example of the confusion that can arise when egress window openings are measured to the sill, as was the case in the previous code edition. Here the sill is 44.5 inches and the finished floor to the top of the sill. Is the sill height 44 inches? Previously the code was not clear on where the sill height was measured from, and the new language of the code removes this gray area. Instead of a ladder, a window area well is permitted to have steps leading out of the well if the depth of the well is greater than 44 inches from the bottom to grade level. This was the case in the 2018 code as well, but some new requirements were added for step dimensions in this version of the code. Previously, the code only said that steps did not have to comply with the rise and run requirements cited elsewhere in the egress section. The minimum width of the inside of the treads is 12 inches, and the minimum tread depth is 5 inches. The maximum riser height is 18 inches. Any addition to an existing structure with a sleeping room must have an egress window opening. Also, any new basement must have an egress installed, unless there is a sleeping room in the basement with an egress window, or there is an attached existing basement that already contains an egress, in which case a new egress opening would not be required. Remodeling of an existing basement does not retroactively trigger the installation of an emergency escape opening as is required for new basements. A new change to the 2021 code permits an operable window of a smaller size to be used in this situation, provided that it follows the rules coming up. Where a change in occupancy in a basement takes place, such as when an existing or unfinished basement is remodeled to include a bedroom, a smaller than standard egress window is permitted. The smaller window is also permitted when a basement addition is installed to pre-existing construction. The smaller egress window must have a net clear area of 4 square feet, which is substantially smaller than the 5 square feet for grade floor openings and 5.7 square feet for standard egress openings. The minimum opening height of the window must be 22 inches, rather than the 24 inches noted earlier in the egress section. The minimum opening width requirement is 20 inches, which is the same as before. An interesting addition and clarification has been added to the 2021 code, which is a new section that describes which stairways are not required to meet code. The first of these new exceptions is for stairways that are not within the home or attached to the home in any way, including to decks and porches. This exception is referring to landscaping or other exterior stairways that may lead up to the building or transition between levels of the home outside of the building. The second new exception is for stairways leading to non-habitable attic spaces. Such stairways would include those drop-down folding type stairs, which are often used to access attics that are floored for storage, but do not contain habitable space. The third new exception is for crawl spaces, which are now explicitly permitted to be accessed by a ladder or other means. This is a common sense addition to the code that most were already following anyway, but now it has been made clear. The walking surfaces of stair treads and landing surfaces cannot exceed 1 in 48 or 2% slope in any direction. A new addition to the code allows steeper slopes, up to 5% or 1 in 20, for exterior landings that also drain water away from the building. Impervious surfaces around the perimeter of the building must be sloped away, and this code permits a greater slope to allow that to happen. This new exception addresses the potential conflict between the minimum drainage slope and the maximum slope allowed for an exterior landing. To comply with surface water drainage codes, an exterior landing can now slope up to the minimum 5% required for finished grade around the structure. Handrails must be continuous from a point over the lowest riser to over the top riser. This means you must be able to place your hand at one end of the railing and not have to lift or remove your hand until reaching the other end. Handrails must either return to the wall or properly terminate into a guard or post. The language of safety terminals that was cited in previous editions of the code has been removed since it was not clearly defined what a safety terminal was. We suggest checking with your local building department to get their interpretation of what is acceptable for a hand railing termination in your jurisdiction. Hand railings must have a minimum 1.5-inch clearance between the railing and the wall to allow for proper grip. There are two exceptions to the continuous handrail requirement. The first is that handrails can be interrupted by a newel post at the turn in the stairs. The second exception is that a volute, turnout, or starting easing is allowed over the lowest tread. An addition to the code here now permits a volute, turnout, or starting easing at the top landing as well as the lowest tread. Spiral stairways have a different set of requirements than regular or winder stairways. The width of a spiral stairway must not be less than 26 inches at or below the hand railing. The minimum tread depth for a spiral stairway is 6 3/4 inches at a point 12 inches from the inside of the tread. This is a reduction from the previous edition of the code, which required a minimum 7.5 inches along the 12-inch walk line. Spiral stairs are allowed up to a maximum of 9.5 inches of rise, and the minimum headroom for a spiral stair is 6 feet 6 inches. This drawing illustrates the required dimensions for a spiral staircase. The minimum width of any tread must be 26 inches, and each tread must have a minimum run of 6 3/4 inches at a point 12 inches from the inside of the tread. Window fall protection is required for windows where the bottom of the window clear opening is less than 24 inches from the finished floor and more than 72 inches above grade level. There is a wording change here that used to read top of the window sill and now reads bottom of the window clear opening, which is consistent with the change made in the egress window section of the code. The idea is to protect small children from opening and falling out of a window onto the ground. Similar to the guarding requirements noted elsewhere, the opening area must not allow the passage of a 4-inch sphere with the fall protection installed. Smoke alarms are an important life safety device that can alert the occupants to a fire in the dwelling. Smoke alarms are required in each sleeping area of the dwelling. Smoke alarms are also required outside each separate sleeping area in the immediate vicinity of the sleeping area. A smoke alarm is required on each story of the home, regardless of the presence of sleeping areas. Smoke alarms are not required on split-level homes with a floor level difference of 1 story, provided that there is not an intervening door between the levels. A new addition to the code permits listed smoke alarms that are marked as helps reduce cooking nuisance alarms cannot be installed closer than 6 feet to permanently installed cooking appliances. These alarms are a UL listed type that have become recently available. Due to the risk of carbon monoxide poisoning fatalities typically happening while people are asleep, the IRC mandates the installation of carbon monoxide alarms near and around bedroom areas. This requirement is in line with that for smoke alarms and applies not just to new homes, but also to existing homes undergoing construction work, making it one of the rare retroactive rules in the code. If construction work necessitates a permit, then the installation of alarms in specified areas becomes mandatory. Carbon monoxide alarms are required in all dwellings that have either a fuel-fired appliance or an attached garage. Carbon monoxide alarms must be installed outside of each separate sleeping area of the home in the immediate vicinity of the bedrooms. Carbon monoxide alarms must also be installed in every bedroom or sleeping room where a fuel-fired appliance is located in the bedroom or in an adjoining bathroom. This could include a water heater, space heater, or a gas or wood-fired fireplace or stove. Where more than one carbon monoxide alarm is present, it must be interconnected with any other carbon monoxide alarms installed. There are a few exceptions to the carbon monoxide alarm requirements for retrofit or repair work on homes. The first exception is for when the work being done to the home is on the exterior of the home only, such as for the replacement of doors, windows, roofing, or siding. The second exception is for the alteration, installation, or repair of existing plumbing work in the home. This type of work would not trigger the requirements of installing carbon monoxide alarms. The third exception is for the alteration, installation, or repair of mechanical systems that are not fuel-fired. This is a change in the wording of the code from the previous edition that exempted all mechanical work. Now, however, if work is to be done with a fuel-fired appliance of any type, carbon monoxide detectors must be installed. Foam plastic insulation is a lightweight synthetic material used as an insulation to enhance the energy efficiency of buildings. It comes in various forms, including spray foam, rigid foam boards, and flexible foam sheets, catering to different applications from walls to roofs and floors. This type of insulation has good thermal resistance and high R value per inch in many cases, but may also be considered a potential fire hazard when installed inside the building. Foam plastic products located in the attic do not have to be covered by gypsum board or 23/32 inch wood structural panel as long as the space is accessible and the space is entered for maintenance or repair only. And it is covered by one of the following materials, which include 1.5-inch thick mineral fiber insulation, 1/4-inch thick wood structural panels, 3/8-inch thick particle board, 1/4-inch thick hardboard, 3/8-inch thick gypsum board, 0.016-inch thick corrosion-resistant steel, which would be minimum 27 gauge, 1.5-inch thick cellulose, or 1/4-inch thick fiber cement board, which is a new addition to the code. Essentially, by having the space entered for repair or maintenance only, a lesser covering is permitted. The decay-resistant section of the 2021 code has had several changes occur this code cycle. Decay-resistant or pressure-treated wood is required for wood joists or structural floors closer than 18 inches to exposed earth, and wood girders closer than 12 inches to exposed earth. Exposed earth or ground is not recommended and not permitted by Alaska's energy code inside the building, but this code applies outside the building as well. Wood that is this close to the ground may be subject to decay from moisture or water coming up from the ground. A new addition to the code now includes wood columns in this section. Wood columns cannot be closer than 8 inches to exposed ground or decay protection is required. This graphic illustrates the various distance requirements for framing members exposed to earth. Where the distances are less than shown, decay-resistant or pressure-treated materials are required. The second location pressure-treated wood is required is for wood framing members that rest on concrete or masonry exterior foundation walls that are less than 8 inches above exposed ground. This part of the code has been changed to include columns as well. Another interesting clarification for this edition of the code is the word directly. This code applies to wood that is resting directly on masonry or concrete and would not apply where separated by a moisture barrier. Wood framing members such as sill plates must be at least 8 inches above grade level at exterior foundation walls, or decay-resistant or pressure-treated material is required. There are two new additions to the decay protection section of the code. The first addition requires that portions of wood structural members that form the structural supports of buildings, balconies, porches, or similar permanent building appurtenances, where those members are exposed to weather without adequate protection from a roof, eave, or overhang, or other covering that would prevent moisture or water accumulation on the surface or at the joints between members. This addition is really targeting uncovered decks with decking boards that permit water to pass through, which could accumulate on the support beams and posts and cause rot or water damage. This illustration shows the requirements for decay-resistant structural members, such as the joists, posts, and beams for decks that have permeable surfaces that are not covered with a roof or other component to prevent water accumulation below. Moisture-permeable decks without roof coverings that don't have pressure-treated structural members are usually a rot problem waiting to happen. The end of this joist was severely water damaged where it abutted the wall of the house. There is an exception to this new addition to the code, which allows non-decay resistant lumber to be used as long as it is sawn lumber, meaning that it has a full 2 by nominal dimension and is not an engineered product, such as an I-joist or other compressed wood product. And it is located in a geographical area where experience has demonstrated that decay-resistant materials are not needed. This exception refers to areas of the country, such as the Southwest, where there is very little precipitation. You would be hard-pressed to find a suitable location for this exception in Alaska. The second addition to the code requires that wood columns in contact with basement floors be decay resistant unless they meet the following two requirements. One, they have to be separated above the concrete basement floor by a concrete pier or metal pedestal by at least 1 inch. And two, they have to be separated by an impervious moisture barrier where a concrete pier is used. Many manufacturers produce metal post bases, such as this, that elevate the bottom of the column at least 1 inch above the concrete slab level, which will permit the use of a non-decay resistant member. Habitable attics are a new addition to the 2021 code. Habitable attics are a way to add an additional living space to a building at the top without having to consider it an extra story. This is helpful where an additional level to the home is desired without exceeding the 3 stories above grade plane limitation in the code, or 2 stories above grade plane in seismic design category D for single-family dwellings. The minimum room areas and ceiling height rules for regular stories of the home apply for attics to be considered habitable. The habitable attic may or may not be considered an additional story above grade plane that would count against the maximum 2 or 3 stories permitted. We will cover those rules next. A means of egress is required in the habitable attic that complies with the egress section of the code, which we covered already. When is a habitable attic not considered an additional story? It has to meet all of the following requirements. The first requirement is that the square footage of the habitable attic cannot exceed 1/3 of the floor area below. However, up to 1/2 of the floor area below is permitted if there is a code-compliant sprinkler system installed. The walls of the habitable attic must be enclosed by the roof assembly. Knee walls which do not extend above the roof line are permitted. The habitable attic floor cannot extend beyond the floor below, meaning that cantilevers are not permitted. When a habitable attic is above the 3rd story above grade plane, which is the maximum permitted by code, sprinklers are required. This graphic illustrates how a habitable attic, if it follows the rules, can be used to create additional living space above the top floor in seismic design category D2, which only permits 2 stories above grade. The use of a basement provides 4 habitable levels to the home on the left. Without a habitable basement, only 3 levels to the home are permitted. Now let's move on to changes to Chapter 4, Foundations in the Codebook. The required footing widths in the code have changed again this code cycle, although not as drastically as in the previous edition. The same general format has been kept, with modifications made to the tables and additions of some categories. The required concrete footing width is based on one of 3 foundation types: slab on grade, crawl space, and basement. The footing widths increase moving from slab on grade to crawl space, and from crawl space to basement, to account for the additional weight of the foundation wall that is added to the structure. The required footing widths are based on several factors. The first factor is the soil bearing capacity. The greater the soil bearing capacity, the smaller the footing is permitted to be, and vice versa. The type of construction also has an impact on the footing size. Light frame construction will permit smaller footing sizes than brick veneer. Concrete or masonry walls require the largest footing sizes as they have the most weight. The number of stories impacts the footing size as well. The more stories there are, the bigger the footing must be to accommodate the load. The amount of snow load also factors into the footing size. Snow loads of 25, 30, 50, and 70 pounds per square foot are included in the code tables. The footing tables assume a building width of 32 feet with a center support wall, so essentially a joist span of 16 feet. Building widths that are larger or smaller have a correction factor that applies. This table has been extracted from the code and gives the minimum footing widths for light frame construction where there is a 50 pound per square foot snow load. Note here that there are some footing dimensions marked in blue, which have been changed from the 2018 code. In general, these changes reduced the required footing sizes. This is the same table as before, except with a 70 pound per square foot ground snow load, rather than a 50 pound per square foot ground snow load. These two tables will cover the majority of Alaska where possible with the building code. Because the code is limited to a maximum of 70 pounds per square foot ground snow load, areas where the snow load is greater than this will have to be engineered. A question you might have after looking at these charts is, how are interior footings sized, since most homes have trusses that bear only on the exterior walls? The answer to this question is that the minimum size of any load-bearing footing is 12 inches by 6 inches. This was not explicitly spelled out in the previous code edition, but came from the code commentary. It has now been included in the 2021 version of the code. The code outlines specific requirements for foundation anchorage, which means how the wall sill plates are attached to the foundation. At a minimum, 1/2 inch diameter bolts are required. These anchor bolts must be embedded at least 7 inches into the foundation wall. The maximum spacing between anchor bolts cannot exceed 6 feet on center for structures not located in seismic design category D. A minimum of 2 bolts is required for each sill plate section, except for very short sill plates, which we will cover next. The anchor bolts must be placed a certain distance from the end of each plate. Bolts can be no closer than 7 bolt diameters from the end of the plate. This equates to 3.5 inches from the end for 1/2 inch diameter bolts. Bolts also cannot be located more than 12 inches from each plate end. A new addition to the code now clearly states the anchor bolts can be wet set into the concrete and do not have to be tied in place prior to pouring the concrete. This is a common practice that is now explicitly permitted in the code. Some clarification has been added to the 2021 edition of the code in regards to placement of the vents. Ventilated crawl spaces must have openings within 3 feet of each corner of the underfloor space. This is a change in wording that used to read 3 feet of the building corners. Now external corners are specified, likely to increase air movement. Openings have been screened, which hasn't changed. However, the code now specifically states that operational louvers are permitted. This means that foundation vents can be openable and closable by the occupants. Many foundation vents already had this function, and installing them was common practice, but now it is specifically allowed in the code. Another interesting clarification allows the openings to not have to be within 3 feet of exterior corners as long as the openings are placed to provide cross ventilation, but only if a Class 1 vapor retarder is present on the underfloor space floor. The crawlspace ventilation section of the code has changed slightly in the 2021 edition. The fourth method permitted for unvented crawl spaces is to use a dehumidifier in the space, which is to be sized per the manufacturer's specifications. This is a change to the code from the 2018 edition, which used to specify a capacity of 70 pints of moisture removal per 1,000 square feet of crawl space floor area. Next, let's cover changes to Chapter 5, Floors, in the codebook. Deck footing sizes are governed by an updated table in the codebook, which is very similar to the 2018 edition of the code, with some minor changes. Footings for decks must extend below the frost line for your local jurisdiction. In Alaska, this can vary from 32 inches to over 50 inches, depending on your location. So check with your building department for the local rules. In any case, the deck footing must extend at least 12 inches below undisturbed ground. This new addition to the code improves the lateral stability and bearing characteristics of the footing for better support of the deck structure. The deck post height requirement table has undergone a significant change in this edition of the code and has been expanded greatly to be more specific for different situations. A simplified deck post height table is shown here. Similar to deck footing sizes, the maximum deck post height is also based on the snow load at the location of the building. The post height is also based on the species of wood used. Common Alaska species are shown in this simplified table, but many other species are available in the full codebook table. Based on the tributary area supported by the post, a maximum deck height is given. You'll notice looking at the table that 14 feet is the maximum permitted height when using this table, no matter what. Heights above 14 feet have to be referred to a design professional. Where the table says NP, it means that the post size selected, in this case a 4x4 post, is not permitted at any height and a larger post will be required. Joist decking spans were amended in the 2021 code edition as well. Each deck joist must be attached with 2 threaded nails or 2 screws at each support joist. The updated table gives the required joist spacing for deck material that is either 1.25 inches or 2-inch thick. Decking that runs diagonal to the joist has a shorter permissible span than decking that runs perpendicular. Decks must be positively anchored to the primary structure of the home to prevent withdrawal and collapse or displacement. The decks must be anchored to resist both vertical and lateral loads. Toe nailing is not permitted to hold the deck to the structure. Toenails are subject to pull-out. A minimum 2x8 pressure-treated ledger is required to attach a deck to the side of the home. Pressure treating is required here to resist water damage and decay. Deck ledgers should not support girders or beams and cannot be supported on masonry veneer. Band joists or rim joist must be 2x material or 1-inch engineered rim board to support the attachment of the deck ledger. Eye joists are not permitted to be used for the rim board where a deck is attached to the home. Fasteners used in deck ledger connection must be hot dipped galvanized or stainless steel to resist corrosion. The ledger to rim joist connection table has been updated in this edition of the code, which we will look at next. This is a simplified ledger-to-rim joist connection table, which specifies the proper spacing of leg screws or leg bolts. The spacing of lag bolts or leg screws is based on the snow load. This simplified chart has 50 and 70-pound snow loads, which are most common in Alaska. The deck joist span is given in this column. As the joist span increases, the spacing of the fasteners decreases to account for the additional load on the deck. Depending on the type of fasteners used and the sheathing thickness of the wall, the on-center spacing of the fasteners is specified. This photo shows an excellent example of covered deck joists that have been toe-nailed to the ledger and are pulling away from the structure. This covered deck could easily collapse with a heavy snow load, an earthquake, or simply too many people. Exterior deck guarding has been added to deck's portion of Chapter 5 to address the issue of deck guards that can't withstand the concentrated loads specified in Chapter 3. The 2018 IRC lacked mandates in this section for the installation of exterior guards on decks. These guards act as a crucial barrier to prevent severe and occasionally fatal falls. The design and construction of exterior deck guards, especially the attachment of the guard system to the deck structure, seldom undergo engineering analysis or testing to confirm their effectiveness. Deck guard connections that are fastened through the end grain of joist or beams are no longer adequate, and additional reinforcement is required by the code. Guard posts which are mounted to the top of the deck must connect to the deck framing or blocking. The connection to the deck board is no longer adequate. 4x4 wood posts, which are commonly used as guards, can no longer be notched at the connection to the deck. Next up is Chapter 6, Walls. Table 602.3.1, which provides the fastening schedule and attachment requirements, has had a few changes in this edition of the code, which we will highlight. The first significant change to the fastening table is right at the top with Item 1. Previously, Item 1 only covered blocking between joists or rafters to the top plate, but now has been expanded to include trusses, blocking between rafters or trusses not at the wall top plates to rafter or truss, and flat blocking to truss and web filler, all with specific nailing requirements. The next significant change was the addition of a nailing schedule for full height header studs into the end of the header. The previous fastening table specified nailing a continuous header to a stud only. The next item that changed in the table added the words rafter or truss to the bridging or blocking nailing requirements for joists. Some changes were also made to wood structural panel, subfloor, and interior wall sheathing to framing nailing spacings and sheathing thickness divisions. The field spacing for 3/8 to 1/2 inch thick sheathing has been decreased from 12 inches to 6 inches. Roof nailing for 19/32 and 3/4 sheathing with 8D common nails has decreased to 6 inches on panel edges from 12 inches. Also, a new nail category was added for deformed 2 3/8 inch by 0.113 inch nails for wall and subfloor sheathing. Deformed nails are nails that have ring shanks or screw shanks, which are much more resistant to pull out and therefore able to be spaced further apart. Next up is Chapter 7, Wall Coverings. The Wall Coverings chapter governs vapor retarders. A vapor retarder is required on the interior side of the exterior wall assembly in our climate. There is an exception for a design that has been approved by the building inspector. A good example in Alaska of an approved design would be the remote wall system developed by Cold Climate Housing Research Corporation. This system uses a vapor barrier or vapor retarder on the exterior side of the plywood sheathing and then adds several inches of foam on the exterior side of that. The code does permit exceptions for vapor retarders, which would include basement walls, the below grade portion of any wall, and walls that will not be damaged if they freeze, such as concrete or masonry. The building code has placed Alaska in climate zones 6, 7, and 8, depending on where in the state you are located, and permits a Class 1 or Class 2 vapor retarder to be used. Alaska has adopted an energy and ventilation standard, with amendments, that adds an additional climate zone for the North Slope and dictates more restrictive guidelines on insulation, vapor retarders, and air sealing. A water-resistive barrier, commonly known as house wrap, is required to be applied over all studs and sheathing of all exterior walls, with flashing to provide a continuous barrier under the siding. This includes gable ends and other walls enclosing unconditioned spaces, all the way to the top of the wall. The water-resistive barrier must be terminated around penetrations such as window and door openings in a watertight manner with tapes or sealants. Flashings are required around exterior door and window openings and must extend to the exterior wall finish. Interior air sealing around window and door openings is also required. Window manufacturer specifications and guidelines must be followed during this installation, and pan flashing is required for windows. Our last chapter to cover is Chapter 8, Roof Ceiling Construction. Rafters that are framed opposite of each other are required to either have ridge straps or a gusset plate installed. Ridge straps aren't new to this edition of the code, but the size and nailing is now clearly spelled out in this edition of the code. A minimum 1 1/4 inch wide strap of at least 20 gauge material is required. The strap must be nailed at least 3 10D nails on each side, with the nail closest to the ridge no closer than 2 3/8 inches from the edge of the rafter. The language in this edition of the code has also been clarified to permit the use of gusset plates or additional collar ties instead of the ridge strap option. A gusset plate or collar tie must be at least 1x4 material, must be located in the upper third of the attic, and must be located at least every 48 inches on center. The code does call out nailing at 4 10D box or 3 10D common nails at each connection. Compliant ridge straps are available from manufacturers in 20 gauge and heavier sizes that comply with these code requirements. That concludes this class. Thank you for taking it, and we hope you learned something valuable along the way. Your next step is to take the quiz that came with this class and submit it for grading. After your quiz is graded, you will receive a certificate via email from our office. If you have any questions, please contact us. You can reach us directly at robert@akinspections.com.